Hello everyone. Today we're gonna solve the validate binary search tree problem. And given a binary tree, we're gonna check whether or not this binary tree is valid or not. So a binary tree is valid if the left subtree of a node contain only nodes with keys strictly less than the node key, and the right subtree have the values strictly greater than the root key. And both left and right subtree must also be a binary search tree as well. So uh, for example, if we have this tree, right? So what we usually do is that we're gonna check whether or not the root node have the value is greater than right node, right? And then we're gonna check the root tree have the value less than value in left node. This case, we can see that this and this is is a valid one. That's basically what we are doing. But is it the right approach? That's the question we should ask ourselves. And I already have the implementation right here. So basically, we're gonna have if the root node equal to null pointer, we're gonna return to right here. And then we're gonna check if the left node, if we have the left node, we're gonna check whether or not we have binary tree on the right, on the left node is valid, and the value at root node is greater than value from left node. And we're gonna do the same thing for the right node. We're gonna check whether or not the root node have value less than value in the right node. So that's basically the idea. But this problem have an issue, and if we submit to Leetcode, we're gonna have a wrong answer in this case. So what's wrong with this approach? So basically, if we check for one, we can see that if we check at each of the node, for example, if we check here, we're gonna see that 4 is less than 5, 6 is greater than 5, so that's okay, right? And if we check at this subtree, we're gonna see that 3 is less than 6 and 7 is less than 7 is greater than 6, so that's fine as well. So but the problem is that these nodes have to have a value that's strictly less than all the value in this right subtree. But we see that the node 3 right here less than our current value 5. So that's when we have a problem. So instead of just consider to the direct parents, we need to consider all their ancestor as well. So that's why our current problem has issue. Now, how can we resolve it? So we're gonna have to store all of the mean value and the max value. For example, we're gonna start from this node, right? And we're gonna have a mean value of this subtree and max value setting. Have the max value of this subtree, right? And then how can we calculate it? So the mean value of this subtree basically is 3, right? Because we have 3 is the smallest value in this subtree. Max value in the subtree is 7. And then when we update to their parent, we gonna update with the mean of this node. Let's say this one is u, right, and the children gonna be v, and the mean of u gonna be equal to mean of the current value right here, right? And then the mean of the left left subtree root, right? So let's say this one is v, so we're gonna have mean of v, right? And we're gonna do the same. We're gonna update max of the parent node, gonna be max of the uh, current value and max of their children. So that's when we can uh, compare the current value, the value at the root, with all of the value on the right subtree, right? So we're gonna make sure that the number of root value is less than max of the subtree of the right node, right? Let's say this one is max of v, and this one is v2, right? So we're gonna make sure that our current root value is greater than, or actually this one should be in v, and to compare with the left subtree, we're gonna make sure that all of the value in the left subtree have to less than the root value. So we're gonna update with the max of v2. So if we have all of these conditions satisfied, we're gonna have a valid binary search tree. That's basically the idea. All right, and let's jump to the coding part right here. So we have a wrong approach. Let's combine it, right? And then we're gonna do a DFS to find the min and the max, and to check whether or not the root node is valid. So like, but to make it easier, I'm gonna create a new struct. I'm gonna call it like just our current node, so that we can store the min value of that subtree and the max value of that subtree. And then to make it easier, I'm gonna have a flag called is a valid binary search tree. And then I'm gonna have some constructor right here. Gonna have the default constructor, gonna be valid bst binary search tree, gonna be 2, and the mean value gonna be a very big number. Let's say I'm gonna have infinity, and the max value gonna be minus infinity, right? And I'm gonna have constant in here, gonna be value this for each big. So I'm gonna say this one is integer max of integer, and this one is min of integer min. That's great. And then in our gonna have, okay, that's look great to me. And then First of all, we're gonna have a root for our function. We have a root node equal to let's say I'm gonna just DFS from our root is, and then we're gonna check, as usual, we're gonna check the edge cases. So if we have a root node be equal to null pointer, which means that we don't have any real tree, we just return 2 right here. Then because I saw the flag right here, so I'm gonna check root node. I'm gonna just return node. Is it a valid BST or not? So, and all the thing we need to do is DBS function right here. So we're gonna have node DBS function with node or with the pointer here. And then first of all, we're gonna have to create our version of the tree node. So we're gonna create a new root. Let's say this one is tree root, right? So we're gonna create a root gonna be equal to a new node with the tree root value. Let's say we're gonna create a min value and max value for a node from the constructor. We're gonna put this and then we're gonna the max value, and we're gonna give the max value as well. Then min value gonna be equal to value max value. That's basically here. And this one we have tree value, right? So we're gonna have tree root value and value. Yes, let's look perfect. And then for the recursion process, we're gonna have, for the DFS process, we're gonna consider the left substrate and the right substrate. So if we have tree root left different with the gonna consider to go left, and we're gonna here right. Okay, and then we're gonna have a let's say a left substrate gonna be equal to DFS from tree root left. We're gonna do the same right here. And then after DFS to the left side, we're gonna consider if we have our current binary search tree is valid. So we're gonna consider the left node first. We have left subtree is a valid BST first, right? And we're gonna do the same right here. Else, we're gonna return false right here. Basically, we're gonna just type the root node gonna be equal to is valid BST gonna be equal here. And then after that, we're gonna check the second condition. For the left node, we're gonna make sure that our current tree root value have the value greater than or the value the subtree. So which means that we're gonna check the tree root value have the value greater than the left subtree dot max value, right? If we have this condition, which means that we are having a valid binary subtree, we're gonna do that right here, and we have the value of current less than the right subtree, but we need to consider the mean one because we want the value on the right subtree have all the value greater than the current root value. And then after that, we're gonna uh, update the mean value and the max value. I'm gonna do this right here. I'm gonna be mean of root value and left of tree mean value. Right here, just flip mean with max value, and then we're gonna do the same for going to the right side. We're gonna have right. That's basically the idea. And the time complexity for this one is O n, with n is the number of nodes in our tree, and then we have the space complexity gonna be equal to O n as well because we need to have a clone version of each of the tree node. Then the topic for this one is of course we need to rewrite the class. So one is a abstract structure, and then basically just write a new struct class. Then we have pointer, this one, cross, and tree, DFS, and a little bit of dynamic programming right here. I think that's all for this problem. Right, compile here, app substrate. Oh, this one. So we need to return, yeah, good. Perfect. And that's all for this problem. Hope this helped you guys to enjoy it and solve it correctly. If you have any question, just leave it below and solve them. Thank you.